So double click on main there, and you'll see this canvas comes up. And I'd like you to scroll over to the left. This is a common trick in AnyLogic models that XJ Tech uses for their sample models, and it's a good trick for you to know as well. The trick is to place, so this area here, from the origin down and to the right, is visible. So that's what's being displayed when you run the model. The area to the left of that is not visible when the model is running. So if you have elements that you don't want to show actively while the model is running, things like this environment and the population there, you don't want to have those things show up. You put them off the screen, okay? Incidentally, you could still get to them for many models. So you can get to them by right-clicking and dragging, or probably command-click on Mac and dragging. And you can go see what's there and kind of poke around at it. Whoa! But generally speaking, it kind of reduces the clutter. Okay, so we're taking a look. Now I'd like you to take a look at the environment here. How are we going to define this thing? Okay, so take a look at the environment. You'll notice that what's selected here is a discrete 2D space. Okay. So we have, in addition to height and width, the scale of the environment, we have spatial quantization that has to take place in columns and rows. And indeed, it's the 500 and 100 I had spoken of which I had spoken earlier. But there's some other elements defined here as well. And I note that this layout type, this is absolutely key. It's easy to miss, but it's key. You'll notice it says arrange. What that means is, does anyone remember last time we looked, when we were going through the different network types, we tried different layouts, and there were several layouts. One was, well, give me an example of a layout we tried. Yeah, spring was one, a ring was another, good. And yet another was arrange. What did arrange do? When we chose that as a layout for, it was a matrix. It was it mapped it out in a 2D pattern, right? And that's exactly what's going on here. That's why this is arranged in a 2D pattern. I mean, so when we run this thing, we get this logical mapping of the cells onto this 2D grid here, okay? And that's because it says arranged. If we had chosen another layout type, we would have gotten something quite different. Okay, so let me just follow this here. I mean, you probably don't want to do it, but you know, if you wanted to try a random layout,
what happens if you say user defined?
I believe by default it's going to go to a random layout, but I could be wrong. But you can then override it, in other words. And yeah, you could find it associated with main, right? Sorry. So this is actually a random layout, and what's going on here? Okay, that's interesting. I don't see something obviously different there. So I'd have to figure out maybe there's something overridden elsewhere. Yeah. Yeah. Well, I was wondering that, but I saw some behavior that made me think that it was, that was what initially crossed my mind, but I saw some behavior that made me think it is communicating with neighbors, so I'd have to go back and take a look. When I was a youth, I spent a fair bit of time in front of this game. Confessions. I wasn't playing Halo or something. Yeah, that's right, yeah. What's that? Yeah, it's more efficient than that. You could actually do it in a much faster way. There's sort of I mean it's going to be n squared in the sense that if you have you know, x times y, or say n times n in each dimension. It's gonna be n squared cells to update, but it doesn't have to for each cell look at sort of all other combinations. So it's you know, it depends how you define your n. If n is the number of total cells, it's not n squared. It's linear. Okay. If n is, you know, the number in each dimension, then yeah, it's n squared. Okay. So in any case, layout type is something that allows it to be on a 2D grid. I'd like to further, though, note that in the neighborhood type here, it selects more. Okay, that's the more neighborhood. That's the name historically given to the 4 cardinal directions. So if your behavior depends only on the 4 cardinal directions, you're said to be in a more neighborhood. In other words, the connectedness of cells, what's considered next to you, only includes north, south, east, and west. So this is a more neighborhood. There's actually several types of neighborhoods that are defined in the cellular automata literature, and this is one of them. Okay. There's another one called Euclidean. That's the other one AnyLogic supports, and that's the 8. Okay. So north, south, east, west, northeast, southwest, etc. Okay. So